Good morning, class. Good morning, everybody. Let us please welcome you all to the class of electromagnetic field, and hope you are doing fine. And we shall be discussing the different coordinate system in this class. Right. I hope my voice is clear to you, and you can just turn off your videos to get a better bandwidth. Okay. So let us move towards our whiteboard. Okay. So I think you can see the whiteboard. Right. Correct. So let us talk about different coordinate system, and we know that the three main coordinate system are: first is a rectangular coordinate system. It is also called Cartesian coordinate system, and the second one is your cylindrical coordinate system. Right. Okay. And then we have our third one, which is called the okay. So I will suggest that you should turn off your audio. Okay. So now we have different coordinate system. One is the rectangular or Cartesian, and second one is your cylindrical coordinate system. And if you talk about the third one is your spherical coordinate system. Okay. Okay. So we have already discussed something about the Cartesian coordinate system. Now let us try to discuss about the cylindrical coordinate system. Okay. So we have the cylindrical coordinate system. Okay, so it's quite easy. We will just draw a cylinder. Okay, and we can just mark our z-axis, which is vertical. This is our z cap. Okay, and then let us consider this point P. Let this be the center. Okay, this is the point P, and this is the center. So there is a radial vector going towards P, and this is called the R. This is called R vector. The direction of R vector is basically outwards toward the radial direction of the point P. Okay, and let us assume that this our axis is x cap. So the angle between P and x cap is called the phi. So this direction is basically called the phi cap. So in the cylindrical system, we have three unit vectors, and they are basically defined as r cap, and then we have phi cap, and then we have z cap. Okay, and all these three direction, the r cap, then the z cap, and then we have the phi cap. All three are perpendicular to each other. That means they are orthonormal or orthogonal vectors. So this is the basis of the cylindrical coordinate system. Okay, okay. So this is the cylindrical coordinate system, and you know that r cap, phi cap, and z cap are the unit vectors, which are orthonormal, orthogonal vectors to each other, where r cap is directed along the radial direction, z cap is along the z direction, and phi cap is the direction of the angle between the x axis and the point mark along the radial direction, right? And r cap, phi cap, and z cap are the unit vectors for the cylindrical system, and all these three are basically perpendicular to each other. And you should remember that z is the height, sometimes denoted by h also, and r is the radius, and phi is the angle between the x-axis and the point on the radial direction. Now let us talk about the top view. So if we look at the cylinder from top, okay, you have a cylinder here, and you want to look from the top. Okay, if you are looking from the top, then you will see this portion of the cylinder. Okay, and we need to observe that what this portion will look like. Okay, so this portion will look like a circle from the top. Okay, and this will be the center. And we have this three direction: r cap, phi cap, and z cap, right? So let this direction be the y cap, and the direction perpendicular to y cap will be your x cap. Okay, and then we need to find the direction of the point which is marked. So let us see what should be the point. So let us see which is the r direction. So the r direction will be this one. This will be your r direction. Okay, and suppose this is your point P marked here, and this direction will be the phi direction. Okay, so if you want to draw this again, this angle is your phi. Okay, let us draw this again along a axis. So the top view of a cylinder will be aligned along the y direction. This is the y direction, y cap, and this is your x cap, and then this is your r cap, and let us bisect this line, and direction perpendicular to r cap will be your phi cap. Okay, and this will be the angle phi, whatever. So suppose we have our r cap, phi cap, and z cap given as 2, 30 degree and 4. So we know that this will be our 2. Okay, and This phi angle will be equal to 30 degree, and the z direction will be 4. Okay, that will be your z direction. Okay, we can convert this cylindrical into Cartesian by just writing okay, we can just write down this as x equal to r cos 30 degree, that is equal to 2 cos 30, which is equal to root 3, and then you will have your y equal to r sine of phi, that will be equal to 2 sine of 30, which will be equal to 1, and then we will have our z cap equal to z cap, that is equal to 4. So in Cartesian, you can write this coordinates as root 3 comma 1 comma 4, that is our x cap comma y cap comma z cap, right? So this is how we can convert uh, from cylindrical coordinate to the Cartesian coordinate system. Okay, so let us do some questions on that. Let us do one question. The question is given as, find the distance between P and Q, where P is given as 1 comma 2 comma 3 and Q is given as 2 comma 30 degree comma 4. Okay, so how shall we solve it? So we have to first of all identify which coordinate system we are using. So if we talk about P, then P is given as 1 comma 2 comma 3, there is no angle. So this is probably, this is the Cartesian system. And the other one, Q, is given as 2 comma 30 degree comma. This is because it is having an angle, then it is probably the cylindrical system. So what we have to do is that we have to convert the cylindrical coordinate into Cartesian. And then we can calculate the distance. So our point Q is given as 2 comma 30 degree comma 4. Okay, so because this is a cylindrical coordinate, we have here r equal to 2 and we have phi equal to 30 degree and we have z equal to 4. So we know that x is equal to r cos phi, which will be equal to root 3, and y equal to r sin phi, which will be equal to 1, and we have z equal to 4. So now we have q given as root 3 comma 1 comma 4, and p is given as 1 comma 2 comma 3. We have to find the distance between them. So the distance will be given as one minus root 3 square plus 2 minus 1 square plus 3 minus 4 square and root, which shall be equal to 6 minus 2 to 3, right? So this will be our answer. So I hope you enjoyed this class, and we shall be connecting with you maybe on Wednesday, right? And stay tuned for the next session of this EMFT class.